Download this code and get free GPT-4o from codegive.com, link in the description below. Double-checked locking is a design pattern used in multi-threaded programming to reduce the overhead of acquiring a lock by first testing the locking criterion without actually acquiring the lock. Only if the check indicates that locking is required does the actual locking take place. This pattern is commonly used in implementing the singleton design pattern in Java. Understanding the problem. In a multi-threaded environment, multiple threads might try to access a shared resource simultaneously. If this resource is not handled properly, it can lead to issues such as inconsistent data states or race conditions. The singleton pattern. The singleton pattern ensures that a class has only one instance and provides a global point of access to it. The challenge arises when you need to ensure that this instance is created in a thread-safe manner. Double-checked locking. Double-checked locking is a technique that minimizes the overhead of acquiring a lock by checking the locking criterion twice. 1. The first check is done without acquiring the lock, to avoid the overhead. 2. If the instance is null, the thread acquires the lock. 3. The second check is done while holding the lock to ensure that no other thread has initialized the instance before this thread does. Implementation in Java. Here's how to implement double-checked locking in Java. Explanation of the code. 1. Volatile keyword. The instance variable is declared as volatile. This ensures that multiple threads can see the updated value of instance immediately after it is initialized, preventing issues with instruction reordering. 2. Private constructor. The constructor is private to prevent instantiation from outside the class. 3. GetInstance method. The first if, instance equals null, check is done without synchronization. This allows threads to avoid the overhead of locking if the instance is already initialized. If the instance is null, the thread enters the synchronized block to acquire the lock on the singleton.class. The second if, instance equals null, check is performed to ensure that no other thread has created the instance while the current thread was waiting for the lock. Important considerations. 1. Volatile. Always declare the instance variable as volatile to ensure visibility of changes across threads. 2. Performance. Double-checked locking provides a good balance between performance and thread safety, especially in scenarios where the instance creation is costly. 3. Java memory model. Understanding the Java memory model is crucial when implementing concurrency patterns to avoid subtle bugs related to memory visibility and ordering. Conclusion. Double-checked locking is a powerful technique for implementing a singleton pattern in a multi-threaded environment. By minimizing the overhead of synchronization while ensuring thread safety, it enables efficient use of resources in concurrent applications. Always remember to use the volatile keyword to avoid issues with instance visibility among threads.